Hello, my dear students. Welcome to science class. So today we will be starting with a new chapter of your science NCERT book, that is chapter number 15, Air Around Us. Okay. So let's see what we are going to learn today. Today at first we will be learning about a short introduction on air and wind. Then we will be learning about the properties of air in brief. Then an activity to show that air is present everywhere around us. Then we will be learning about the concept of atmosphere, followed by the composition of air, and at last activity to show that air is a mixture of gases. So let's proceed. Now what is air? Air is actually a gaseous mixture. That is what that is. It is a mixture of several gases. Now we cannot see or smell air, but air is present everywhere around us. Okay. All living things, they require air. Air is inside the human bodies as well as in the bodies of other animals and birds. Why? Because air is necessary for the breathing of all the living things. Right? No living things can survive without air. We can live without food and water for few days, but we cannot live for more than 2 minutes without air. Okay? So air is present on ground, on the top of trees and buildings as well as high up in the sky. Air, it is also present in the soil. Some air is present even in the water of ponds, lakes, rivers and oceans in the dissolved form. Okay. Now, though we cannot see the air, but we can feel its presence when it starts moving or blowing. Okay. And moving air is called what is called wind. Okay. Now this wind, it makes the clothes hanging on a cloth line sway. Okay. The air blowing in a garden stirs the leaves and branches of the tree as you can see in the picture, right? When a fan is switched on, then air is moved by the blades of the fan, makes the pages of an open book flutter back and forth, right? Now it is the moving air which makes it possible for us to fly a kite in the sky. And it is also the moving air which pushes the sails of a sailing boat and makes it move in water, right? In agriculture, this moving air or wind, it helps us to separate husk from the wind grains during winnowing, as you have already learned in the previous chapter, right? High speed winds can even uproot the trees and blow off the tin roofs of houses and factories, right? Now, sometimes we have seen that many little children, okay, they play with this firki or the wind vane, okay, this kind of thing, okay. Now, when a child holds the stick of the firki in his hand, stands in an open area and adjusts the direction of firki blade, the firki it starts rotating like this, okay. So, it is the moving air which makes the firki rotate, right? Another device which works by utilizing the moving air is what is the weathercock. This is the weathercock. Okay. In a weathercock, what happens? The broad blade in the shape of a cock, it is fixed on an arrow which is attached to a rotating axis. Here you see. It is attached to the rotating axis. This is the axis. Okay. So, when the air pushes the cock blade, then the cock and its arrow rotate and align in the direction of moving air. Thus, weathercock, it is a device which shows the direction in which the air is moving at a place. Right? Now, next. What are the properties of air? Number one is what? Number one is air. It is present all around us, but since it is colorless, okay, so we cannot see it. So air, it is what? It is colorless, tasteless, odorless, gaseous substance. Number one. Number two, air has mass. Number three, air occupies space. Number four, air dissolves in water. And number five, air can be compressed. Okay. So each of these statements, okay, it has got some proof, okay, that this statements it shows right. For example, air has mass. The first statement, okay, like if you take two balloons, suppose this is two balloon, one is X and Y, and if you just hold it, okay, in this hanging rod, okay, then what you will find that this is in this kind of position, okay. That means both of the balloon has got equal mass. That means equal amount of air is present in it, okay. Now you just deflate one balloon. You just deflate this balloon X, okay. You just prick a needle and you just take all the air out. Now immediately what you will find, just like a common balance, what you will find the Y, the balloon Y, it will come or it will tilt downward. Now why it will tilt downward? As because it is heavier, and as because the deflated balloon, it is lighter than the inflated balloon, so it will go what? It will go up. Okay, so this experiment, it proves that air has mass. Next is air occupies space. Now, air occupies space. For this, you take an empty glass bottle, okay, and hold it in an inverted position, or simply you can take a glass, hold it in the inverted position with its mouth, open mouth facing downwards, okay. Now, this inverted glass, okay, it is put in the water kept in the vessel, okay, as shown in this figure. Now, what you will find that water does not enter inside the inverted glass, okay. The water does not enter into the inverted glass, it is already filled with air, okay. Now actually all the space in the bottle or this glass, it is occupied by air, okay. The air present in the empty glass, okay, it prevents the water from entering it, okay. So from this activity, what you can conclude that air occupies space. Now, if you tilt this glass, here you see you are tilting the glass, okay, then what you will find that air present in the bottle, it goes out in the form of air bubbles. Here you see air bubbles, right? So, as the air from the bottle escapes, okay, so the water starts entering the glass. Actually, what happens, the space vacated by the air leaving the bottle is now occupied by water, okay. So this activity shows that this glass, which appears to be empty to us, but it is actually what? It is actually filled with air. Next, air dissolves in water, okay. Now if you take a vessel, okay, with half filled with water, and if you just put it over a burner, after some time what you will find that this kind of bubbles are being formed, okay. Why this kind of bubbles are being formed? As because what? It is trying to, it is escaping as what? It is escaping as vapor, okay. So this proves what? This proves that air is dissolved in water, okay. Next comes what? Next comes the concept on atmosphere, okay. So we live on earth, the blue planet, okay. Now the earth, it is surrounded by layer of air, okay. Here you see this is the layer of air, this is our earth, this is the layer of air that surrounds the earth, okay. Now this envelope of air that surrounds the earth is called what? Is called atmosphere, okay. Now this atmosphere, it extends up to many kilometers above the surface of the earth, right? Now we live within the atmosphere of the earth. Now atmosphere, it is what? It is essential for life on the earth. Air of the atmosphere, it provides us oxygen gas for breathing by all the living organisms, including us, okay. And as we go higher up in the atmosphere, then what happens? The amount of air, it becomes less and less, right? Now the air at the top of very high mountain, it is so thin that it does not have enough oxygen for the people to breathe properly. So the people who climb high mountains, always you will find that they are carrying oxygen cylinder with them. They breathe in oxygen from this cylinder so as to survive on higher mountains, okay. And here you see these all are what? These all are the layers of atmosphere, okay. The first layer of atmosphere is the troposphere, okay. Next comes the stratosphere, okay. In between troposphere and stratosphere lies the ozone layer, okay. Then comes what? Then comes the mesosphere, then thermosphere, and at last what? At last the exosphere, okay. You have already learned in class 5 about the layers of atmosphere, okay. Now, composition of air. That means what does air contain? Okay. So, we will now describe what air is made of. This is called what? This is called the composition of air. Now, we know that air is a gas. For a long time, people thought that air was just a single gas. Now, it has been proven by experiments that air is not a single gas. Rather, air is a mixture of many gases, right? And the major component of air, it is what? It is the nitrogen gas. As you can see in this pie chart, this kind of graphical representation is known as pie chart. And in this pie chart, you can see the maximum amount of gas which is present in the air is what? Is nitrogen gas. That is 78%, 4/5 of air, right? The second major component of air is what? It is the oxygen gas, which is shown by the red bar. Okay. And about 1/5 of the air, it is what? It is oxygen gas. Now, in addition to nitrogen and oxygen gases, air also contains what? Small amount of carbon dioxide, water vapor, and some other gases. That is the inert gas. That is argon, neon, krypton, xenon, helium. Now, the air may also contain some dust particle. Okay. So, what we can say? We can say that air is mainly a mixture of nitrogen and oxygen gases with small amount of carbon dioxide gas. That is what? That is 0.03%. Water vapor and other gas. So, together carbon dioxide, water vapor and other inert gases, it constitute 1%. Okay. That also includes the dust particle. Okay. So this composition of air, it is represented by this pie chart. Okay. Now the composition of air, okay, it also changes slightly from place to place and from season to season. That is, air over the industrial cities, okay, it usually has higher amount of carbon dioxide in it than air over the open spaces. Okay, as because in industrial cities there are more and more factories. Okay, so more and more factories, they liberate what? They liberate more and more carbon dioxide gases, isn't it? Okay, now air in the coastal areas, okay, it may has more humidity or more water vapor than in inland areas. Okay, and during rainy season also, what happens? The water vapor, it is present in the uh, air. Okay, more water vapor is present in the air, right? Now, similarly, the amount of dust in the air is more in windy place than in other areas, right? Now, the next one is activity to show that air is a mixture of gases but not a single gas. Okay. So, for this, you have to take a trough. Trough. This one is known as a trough. Trough means what? Trough means a kind of vessel. Okay. And place a gas jar stand in it. Okay. So, this is what? This is glass jar, gas jar, whatever you can say. Okay. Now, fix a candle on the glass jar stand. Okay. Now, fill the trough half with water. Okay, here you see, fill the trough half with water. Okay, and dissolve some caustic soda or sodium hydroxide in this water to form caustic soda solution. Okay, over here. Okay, the water must contain caustic soda. And if you want, you can add some few drops of ink. Okay, in order to color the water. That is optional. It is your wish. Okay. Now, to start the activity, at first what you have to do, you have to light the candle with a matchstick. Okay, so light the candle. Here you see the candle is lighting. Now, cover the burning candle by placing the inverted glass jar over it. Okay, just you place the inverted glass jar over it. Now what you will find? You will find that after a short time, the candle stops burning. Here you see the candle has stopped burning and water, it rises up in the glass jar. Here you see the water. It is the initial level of water. Now the water, it has risen. Okay, inside what? Inside the glass jar. Certain level. Okay. Now the question comes that why the candle stopped burning? The candle stops burning because all the oxygen which was present inside this glass jar, okay, it was used up by the burning candle. Okay, and you all know that oxygen, it is a supporter of combustion, right? So when the oxygen present in air contained in the glass jar is all used up, then what happens? Then the burning candle is get extinguished. Okay. Now, when the candle burns, okay, then the oxygen of air in the glass jar is used up and carbon dioxide gas is formed. Okay, naturally with burning carbon dioxide gas formed. Now this carbon dioxide gas is absorbed by the caustic soda solution in the trough. Okay, the carbon dioxide gas which was present inside it, it is absorbed by what? It is absorbed by the caustic soda solution in the trough. Okay. Now the absorption of this carbon dioxide gas by creates a vacuum inside the glass jar. Vacuum means no air. Okay, no pressure in the glass jar. Okay. So certainly in order to fill up the vacuum, what happens? This water, it rises up in the glass jar to fill this vacuum. That is why what happens? It rises up. Okay. Now, water in the glass jar, it rises to about one-fifth part of the volume of air initially present in the glass jar. Okay. Now, the volume of water risen in the glass jar, it is equal to the volume of oxygen present in the air in the glass jar, which was consumed during the burning of the candle. Right. So from this, what we can say? We can say that about one-fifth of the air is oxygen. Okay. The major part of the air is not used up by the burning candle and remains behind in the glass jar is nitrogen. That means this part is what? This part is the nitrogen, the maximum air. Okay. So since the water does not rise in the remaining four-fifth part of the glass jar in this activity, so it shows that about four-fifth part of the air is what? Is nitrogen. Okay. So thus this activity, it concludes that air is not a single gas, rather it is a mixture of gases, right? So in our next class, we will be discussing about all the components of air in detail. That means we will be learning about nitrogen, oxygen, then we will be learning about carbon dioxide, water vapor and dust particles. Okay. So till then, thank you everyone.